In this video we will see about PSD, that is power spectral density. So PSD is nothing but the power in present in 1 hertz frequency or 1 hertz bandwidth. Its unit is watt per hertz and its notation is SXXW or SXXF. As per the Wiener-Kinche theorem, so we are discussing it for the stationary processes which are power signals. So for that we are finding the power spectral density. So as per Wiener-Kinche theorem, this Rx tau, that is autocorrelation function of that random signal or the stationary signal, is gives the Fourier transform or autocorrelation function, and the power spectral density forms the Fourier transform pair. That means if you take the Fourier transform of autocorrelation function, you will get the PSD, power spectral density. So the formula for power spectral density is SXXW is nothing but minus infinity to infinity Rxx tau e raised to minus j omega tau d tau. Now what is this formula? This is Fourier transform formula. Fourier transform of Rxx tau. So Fourier transform of Rxx tau is nothing but SXXW. Now if you want to find SXXW at SXXW at W equal to 0, then you have to put here 0. So you will get minus infinity to infinity Rxx tau d tau. So what is this? This is area under Rxx tau curve. So SXX0 is nothing but area under Rxx tau. So what is Rxx tau then? Rxx tau is inverse Fourier transform of the SXXW. So this is the formula for inverse Fourier transform. So here SXXW is written and here e raised to j omega tau d omega is written. So if you have given it in terms of f, there will not be 1 by 2 pi. So if you want to find from this if you want to find the Rxx0, so here you have to put it as 0, tau as 0, then you will get 1 by 2 pi SXXW into dW only. So what is this? This is nothing but area under S. This is nothing but area under SXXW. So Rx, or if you here put tau equal to 0, then you will get area under SXXF. So here only area divided by 2 pi is there and here area is there. So why we are finding Rxx0? Because we know that we have seen in previous videos that Rxx0 for the stationary random process is nothing but the total power. So total power we can give it as area under SXXW divided by 2 pi or area under SXXF. So total power you can find with the PSD. If you take the total area with the PSD graph, you will get the total power. So Rxx0 is total power, which is nothing but area under SXXW. So how we can write this area? We can suppose this is your SXXW and here W is there. So you have to go from minus infinity to infinity. So if you make it like 0, this is 0 minus and 0 plus. So this range is 0th frequency range. So 0 frequency range means DC. So for this range you will get the DC power, and for this range and for this range you will get the AC power. So it is written it like that. 1 by 2 is at it as it is. 0 minus to 0 plus is SXXW dW, and minus infinity to 0 minus SXXW dW, and 0 plus to infinity is SXXW dW. So these two here you can see that this is minus infinity to 0 minus and 0 plus to infinity. So this is AC power and this is DC power. So DC power and we know that the total power is nothing but the AC power and DC power, combination of AC power and DC power. We have already seen this expression, E x square T is equal to sigma x square plus sigma plus mu x square. Why I am writing only sigma x square? Because we have seen that for stationary random processes, sigma xt is constant, that is sigma x square, and mu xt square is also constant, that is mu x square. So if another important point is that we know that in this short duration there should be some impulse present, then only we will get this value as some non-zero value. So DC power is non-zero only when there is a impulse present in the PSD graph. If this is the PSD graph, then here should be some impulse present, then only we will get DC power equal to non-zero. If there is no impulse here, then DC power is equal to 0, then only that area will be 1 na? Otherwise the area will not be 1. So there should be impulse present. So what we have studied from the PSD graph, that PSD, why PSD is important? PSD, with PSD graph we can find the total power, and that is a Fourier transform pair between the autocorrelation function and PSD. If xt is real, PSD is even. Total power is area under PSD. DC power is area under PSD in zero frequency range. And DC power is non-zero only when there is impulse at in zero frequency range. So this is all about the PSD.